Now, as advertised, we didn't get to go through all of the problems that I had. I always usually try to get a set that'll certainly last us throughout the class, and the intention was to pick up on that next time, and we actually made pretty good progress today. Anyhow, I wanted to end with a note on factoring. So, how do we factor x squared plus 3x minus 4? Well, we can see just from what I've written down here that it factors into x plus 4 times x minus 1, because 4 times x minus 1 times x gives us 3x. 4 times negative 1 gives us negative 4, and x times x gives us x squared. Now, you know from having written things out using the distributive law that what you get is going to be this times this plus this times this plus this times this plus this times this. Everything here multiplies everything here, and we just have to investigate the numbers and do a little bit of experimenting. Now, maybe a whole lot of experimenting, because it's not always easy to factor a given expression, but we use that familiar procedure that I find people seem to or tend to know quite well when they come to us. The SOL is big on factoring, so people usually come out of high school being pretty good on factoring. Well, I then asked the question, what number would we add to x squared plus 2x in order to get a perfect square? Now, this orange 1 and this orange 1 weren't there. Okay, so how's that going to work? Well, we see that in order to get 2x here, if we're going to have the same expression here as here, in other words, we're going to have the same binomial to get a perfect square, I'm going to have a 1x from this one and a 1x from this one. And that's going to give me 2x. So the 1x here and the 1x here give me 2x. And then when I multiply all this out, well, x plus 1 times x plus 1 will be x plus 1 quantity squared. When I square that, I'm going to get x squared plus 2x plus 1, meaning that in order to make this into a perfect square, I have to add 1 here. And that's going to give me quantity x plus 1 squared. Now we went over here and tried to apply the same thinking to x squared minus 6x. Okay, if it's going to be x squared minus 6x and you're going to have the same thing here, then you'd better have a minus 3 here to give you a minus 3x. And of course you have to have a minus 3 here to give you another minus 3x in order to get the minus 6x. Now when we multiply these out, we get x squared right there. The minus 3x and the minus 3x give us the minus 6x. We're going to have to add a 9 to this in order to get x minus 3 quantity squared. Now that's a very important process. We'll talk about it more in the upcoming class, but I wanted to introduce that. It's called completing the square, and we'll see how it works out, because by completing the square, we can get an equation of a circle, which might not look like the equation of a circle, into this form: y minus something squared plus x minus something squared equals another number. And that is going to be the form of the equation of a circle, and then we can graph the resulting equation. So it's a very powerful method, and we'll be looking at it more closely in the next class.